Hello, I'm Gustav from Czech Technical University, and this is a pitch for our paper, A Deep Learning Blueprint for Relational Databases. And as the name suggests, it's an extension of deep learning to deep relational learning so that we can learn straight from relational database formats. The data format of relational databases differs significantly from the tabular data format normally used in machine learning in that we may have several tables or relations that are interconnected with foreign keys. This means that the rows in these tables, composed of the individual column attributes, can no longer be considered as IID learning samples, and we need to take into account the structure of the whole database. Particularly, we consider the structure of a database as a two-level multi-relational hypergraph, where the relations from the individual tables form hyperedges over their respective column attributes, and these are further interconnected by another set of hyperedges corresponding to the foreign key constraints between the different relations. The main contribution of our paper is an introduction of a modular neural message passing scheme on that multi-relational hypergraph representation, effectively allowing for end-to-end deep relational learning from databases. Now, this is a depiction of the scheme's architecture, composed of three main types of differentiable functional interfaces we refer to as transformation, combination, and aggregation. Now, viewing the data flow from a selected referencing table's point of view, we start by embedding its column attributes into real-valued embedding vectors with respect to their semantic types, resulting into a tuple of such vectors for each row in each table. Now, these further undergo a learnable tuple transformation, mapping the tuples to another same-size tuples that are subsequently combined with the tuples from the reference tables following the foreign key relations. Now, the resulting sets of related tuples from the reference tables are further aggregated with respect to each row of the referencing table. And finally, we aggregate these over all such reference tables, yielding a transformed representation of the same dimensionalities as the input database so that the whole architecture can be stacked in layers. We compare several instantiations of the blueprint against representative models from the fields of statistical relational learning, propositionalization, and neural symbolic integration, showing some promising initial results. Finally, the framework also offers some additional features such as automated schema detection so that the whole thing is fully automatic given simply a database connection string. Now, you can find the framework on GitHub, where you can also reach out to us if interested. Very much looking forward to that.